All right. Is that a bit better there? Just making sure everybody is okay there. Let me put that down there. Sorry about that, everybody. Okay. Sorry, I just had to make a few settings changes. I want to be sure that at least the stream is stable as best as I can. So, you know, try my best here. So apologies about that. All right, perfect. Okay, so let's go ahead and restart here for just a second. All right. So, all right, cool. Hey, Brianna, how are you? Um, okay, so again, we're going over subtraction here today. Again, I'm just starting off here with the with this third example here, 429 minus 318. Again, we line up the numbers here. Once again, we go ahead and just do, say, 9 minus 8, which is 1, 2 minus 1, which is 1, and 4 minus 3, which is also 1. So we would get 111 here as our final answer. Okay, so not too bad, pretty straightforward. Okay, now that part there again, I think you guys know that rather well. I think that's pretty easy. But let's take some other examples here. Now let's start off with something basic here, and then kind of work our way up to tougher examples. So I'm going to take say number 5 here. This is on page. Let me go ahead and reference the page here, really quick. This is page 14 in your notes there. So if you want to kind of follow along and be like, okay, where is he coming up with these examples? This is page 14 in the notes. All right, so I'm going to go ahead and just kind of clear this all out. So let's just kind of undo everything here. All right, so let's start off with 80. Let's start off with 86 minus 38. Okay, let's start off with that. So we'll go with the 86 minus 38. Okay, so here's our problem right here. Now, to do subtraction by hand, the way we want to kind of approach this particular type of problem is to first take a look here and say, all right, you see this top number here is 6. All right, so this top number here is 6 is less than the bottom number here of 8. So instead of looking at this as 6, instead we're going to consider it as 16. So 1 6. Then we do 16 minus 8. And 16 minus 8 here is going to be 8. All right, but there is a consequence. The consequence is that because I considered this 16, I had to get the 10 from somewhere. The 10 here came from the next column over to the left. So this 8 here now becomes a 7. So now we have 7 minus 3, and that becomes 4 for 48. So again, what's the key here if you're trying to do subtraction by hand is to borrow 1, i.e. 10, from the next column to the left. Let me go ahead and type that out here. All right, so one of the keys to subtraction is, if necessary, borrow 1 from the next column to the left. Okay. And I'll add a little note to this in just a second, but that's one of the keys here to subtraction, is to borrow 1 from the next column to the left. Now, are there, before we move on here, I apologize, are there any questions so far that you have? Okay, I just want to be sure that it's clear and that it's understandable. No, no questions. Again, type no in the chat, or again, if you do have a question, please let me know. Okay, that's perfectly fine. All right, let's go ahead and move forward then, and let's take a look here at the next example, and I'll show you kind of like the exception here to the rule. Okay, so let's talk about the exception to the rule here in some of these questions. All right, so I'm gonna kind of skip around here. Again, you'll see exactly kind of what we're talking about here. So I want to specifically look at letter C, and we'll look at a couple more examples here, and you'll see why I want to kind of focus on those types. So this is the next page over, page 15, but I'll go ahead and write this down here in the little paint thing. All right, so we'll put down 7,024 minus 2632. Okay, so this is our problem right here. Now we're just going to go through the motions here. All right, so we have 4 minus 2 here. All right, and that's going to be 2. Okay, so that part there, not so hard, very straightforward. Here we have 2 and 3 here. All right, so we're now going to imagine, just like the last example, we're going to imagine that this is 12. So we get 12 minus 3, and 12 minus 3 is going to be 9. All right, now this is the part where I kind of want to focus in on. Now, like I said in the last problem, we had to borrow 10 from the next column to the left. But here we have a 0. Okay, now I can still technically borrow 10 from the next column over, but maybe not in the way that you think. Now, the way it works is it looks like this. If I have a 0 here in the column to the left, okay, so if I have a 0 here into the column to the left, let me go ahead and make this a bit bigger here, and then add the word notes here. So exception, if I have a 0 in the column to the left, then change the 0 to a 9. All right, and then borrow, and then basically borrow 1 to the left of that column. All right, now what exactly does that mean? All right, you're probably saying, whoa, okay, hang on a second. What exactly are you talking about here? All right, fair enough. It's a fair question. So I made this 12. I made this 12 minus 3, that's 9. All right, now I'm going to make this, I'm going to change the 0 to a 9. All right, but in order for me to change this to a 9, I'm going to have to borrow 1 from the next column over. So this 7 now becomes a 6. So now we have 9 minus 6, which is 3, and 6 minus 2, which is 4. So here we get 4392 as our final result here. Are there any questions about that so far? No? Okay. Let's go ahead and try another one. Okay, we'll try another example here. All right, and let's take a look on how that'll work out. So let's look at these two here. Okay, 4,000 minus 1782. All right, so let's just check that one out. All right. So I'll just write it on here. All right. So here's 4,000 minus 1782. Now, just to get started with this problem here, just to be on the safe side, what we want to do here first is, again, we're just going to consider this first zero here to be a 10. Okay, that's what we're going to do here first. All right. So here we have, again, 10 minus 2. So I'm just going to start you off here as an 8. Okay, so that's what we have here. All right. So here's the next question. What should I do next? What should I do next? All right, change the 0 to a 9. All right. Now I agree with that. Let's change that 0. Let's change that to a 9. But if I change that to a 9, what do I have to do next? So I agree. I changed that 0 to a 9 just like the last example. But what should I do next then? What's the consequence for me changing this this 0 here? Take 1 away from the next column, okay? So what am I going to change that to? What am I going to change this 0 to then? So that's correct. I'm going to be borrowing, quote unquote 1 from the next column. But what should that change to? Make the 0 a 10. I can't make this 0 a 10. I'm going to have to borrow 1 from this column here. So I'm still going to borrow 1 from here. So if I'm borrowing 1 from here, what do I have to do here? Right. That's correct, Natalie. I actually still have to keep the same process here. That's okay. That's okay, Hannah. No problem. But I made the 0 a 9, so what else do I have to do? Now I have to do what you suggested there, Hannah. I have to change this 4 into a 3. So I had to do this 2 more times because, again, because of the exception to the rule. So because of the exception to the rule here, again, if I have a 0 in the column to the left, then I have to change the 0 to a 9 and then borrow 1 to the left of that column. So this could keep going as many times as I need until I change every column over, possibly, which in this case, that's exactly what happened. Okay, so just want to point out that we can certainly do that here in this case. All right, that's correct there. Yes. Okay, so here we have 9 minus 8. That's going to be 1. 9 minus 7, which will be 2. And 3 minus 1, which will also be 2. And then we get our final answer here of 2218. Okay, cool beans. All right. Are there any questions about that one? Oops. So hopefully that made sense there about how to do some of the basic subtraction there. I think that that's very important, so you understand the exceptions to those rules. Those are, again, definitely a thing. Okay. Let's go ahead and take a look here at some application type problems, and let's see exactly what we're working with. All right, so we're going to be using this table here. This is on page 17, and we're just going to take a look and kind of figure this stuff out here. So it says here, how much more, yeah, actually change this here. There we go. How much more, I guess I should say, how much more does a person with an Associates of Arts degree earn each year than a person who is not a high school graduate? All right, so how much more does an Associate of Arts make than a person who's not a high school graduate? All right, so taking a look here, how could we set up this this particular word problem? What should we do? Yeah, sorry. It is a, sorry. My bad. Let me try 200, see if that makes it better. There we go. Is that better, Yvonne? Okay, cool. No problem. Here to help. So I guess let's go back over the question here. How exactly can we set this up here? What should we do? Okay, that's really close. I agree with 71,900, but it says not a high school graduate. I think you just looked at the wrong number there, which is fine. There you go. All right, so we're doing some subtraction here. All right, so let's go over our little guy here. Okay, I'll just blah 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 blah. All right. So let's go ahead and see what we got here. So we have 71,900, which is again the amount of money that you make if you have an associate's. All right, minus 40,200. Okay. All right. So let's go ahead and subtract each of these. So you get 0 and 0 and 9 minus 2 7 and 1 and 3. So the difference here is $31,700 for your average there. Nice. Hmm. Okay. This example is it's a good word example, that's for sure, but I just don't like the numbers, that's all. So I'll be honest with you, not a big fan of the numbers here. Would you want us to label it? Yes, that would be preferable if you could label it, please. Because I want you to put it with the correct context. I'll be honest with you with this problem here. Actually, let's go with the realistic case here for just a moment. I'm just going to do a little sidebar here. This is actually a really good example about why numbers can be a little tricky in terms of, now by itself, the problem here isn't too hard. It's actually the data that I want to look at. When you talk about data that's kind of presented to you, whether that be in the media or whatever, you have to take sometimes some of the data with a grain of salt. This would be one such example. The reason is because average doesn't really reflect what you would actually get paid, all right, in the real working world. If you don't have a high school if you don't have a high school diploma or a GED or whatever, your average is $40,200. That's very unrealistic. I'm pretty sure that, you probably wouldn't get paid that much. The problem with average is that average talks about all the salaries gathered up into one and then divided it out. The problem with average is that one really large value, so a high school graduate made, $100,000. Well, that would skew the average very much in, you say, that would skew the average very high because you have one very large number and a bunch of lower numbers, for example. What you really want to look at here is if you want to find out what your actual salary probably should be realistically, depending on what field that you go to, the thing you want to look at here is what's called median. Okay, so median, you've probably heard of median before, but median here takes all the data, takes all the numbers that reflect the salary if you have whatever education level in this particular case, and looks for the very middle number in that particular data set. And it will give you a much more realistic expectation in terms of what you should be expecting depending on the level of education that you have. So average is great to an extent in some cases, but not every case. All right, and in not every case, median is actually a much more realistic expectation. So if you want to be a computer scientist, you can type out, hey, I have a bachelor's in computer science. What's my median salary? What's my expected median salary? All right, your expected median salary is 55,000 or whatever. I don't know. I'm just making up a number, but again, like I said, average is not the best. Its median salary is by far and away much, much better in the long run to see what reality really should be thrown your way. So while this is a nice little chart, it's really not realistic because of the fact that average doesn't do a good job of promoting uh, promoting what you should expect out there. So, all right. So just want to put that out there. Math is definitely a thing that you have to interpret very carefully. Okay. All right, let's look at letter B here. Okay, so letter B says, how much more does a person with a bachelor's degree earn each year than a person with an associate of arts? So how much more does a person with a bachelor's make than an associate of arts? So, how would we do this problem here? What would we do? How do we set that up? I'll again go back here for a second. Let me zoom out just a little bit here, sorry. I wish there was a custom one, but I guess not. It's too bad. Alright. Oh, okay. It is that time. Alright, very good. Nice, nice. I agree with that. Alright, so let's go over 100,000. So we'll go 100,000 minus 71,900. Oh, no, it's okay. You don't have to worry about the commas. Look, the commas are there. Like, if the commas are there, if you want to keep organized, if that helps you organize. If you don't want the commas there, that's fine too. Whatever you feel comfortable with at the end of the day. All right, I'm not gonna mind either way. I like I mentioned here last time, it's made for organizational purposes, but you don't have to use it if you're comfortable. But if you do want to use it, you can put like this, that's fine too. I didn't use commas in the last example, but I can use commas here in this case if you want. I got no problem with that. Again, at the end of the day, the commas are a preference if you feel like that keeps you better organized, okay? And that you're like, okay, this number lines up with this number, and so on and so forth, okay? So, you know. All right, so these first two are 0. We got 0 and 9 here. What's this? We got 0 and 9. What's that? We got 0 changed to 10. Okay. Now, if I change that to 10, what should happen there? I agree with that. What should happen over here? Change to 10, yes. No, that's cool. I like that, Natalie, though, because you are correct. If I were to do this next step here, yes, I'm going to change that to a 9. So I agree with that. But I change this to a 9. What else do I got to do? 99? Okay. So that's right. I got to change this to a 9 as well. Agree with that. But if I change this to a 9, I'm going to change this 1 to a 0. Yeah, that's right. That is correct. So now let's just go ahead and do it straight up. 10 minus 9, 1. You can put that comma there if you like. 9 minus 1, 8. And 9 minus 7, 2. Solid. All right. So $28,100 at the end of the day. Cool. All right. Hopefully that became a bit easier to do. Okay. That's the idea anyway. Hey. Okay. All right. Any questions about subtraction there? Why would I change like these two guys to a 9, but not this first one here? If that's what you're talking about, Iman. Because if that's the case, the reason why, yeah. So this first one here, these first two numbers here are zeros, so you can just subtract 0 and 0 there, no problem. Once you get to this situation where you have the top number being less than the bottom number, that's when you start borrowing. So that's why we're making this 0 a 10, all right? And then you have 10 minus 9, which is 1. But then you have to borrow from this side here, so this 0 becomes 9, because now you've fallen into the exception. And then you have to borrow again because you still have the exception here. The 0 becomes a 9, and then you borrow again, making that 1 a 0. Okay, so that is the reason why you have to do it. You do it that way. Is like once you encounter where the top number is less than the bottom number, you then go through the motions from there, just like we did the last couple of examples there. So just like we did for the previous one with, let me go back here for a second. Like we did for 4,000 here, we first did 10 minus 2, which was 8, but then we changed both of these to a 9 and this to a 3, and then proceeded to go ahead and do that. Yeah, I know that's, yeah, Iman, I totally understand. Like that could be a little confusing there. That's, but yeah, I just want to clarify to you, be like, hey, yeah, I could see where you could get the basis of confusion where that can come from. So just wanted to make that clear, and that way, again, you understand that we're using the exception here a couple of times. So yeah. Are there any other questions? Change to 0 to a 9, yeah. And I have it. Okay, subtract the next whole number. I hope that makes it clear for everyone. So again, you're not caught unawares. No? Okay. All right. Let's go ahead and take a look here at the next section. Now the next section, we're going to skip section 9.1 here in the notes. We're going to come back to chapter 9 here towards the end of the course. This talks about sign numbers here, but I don't want to get too heavy into sign numbers just yet. I want to go over the basics here first, and maybe we'll do sign numbers here a little bit later, but we're going to go ahead and skip like 9.1, 9.2 for now. I just want to make, I did this last semester with chapter 9 in the middle, and I found out it just made things a little more confusing than they needed to be. So I'm going to go right to section 1.4 here. You have a question with the homework? Go ahead. Go ahead, Yvonne. When are you supposed to use and question, or when you write it out, don't use and question. You have a homework question as well? Okay. When are you supposed to use and I'm a little use oh, okay. Um so if you're writing out the number, yes. I'm a I'm a little confused. If you're talking about like writing out the number in words, like 1000 for example, Yvonne. I just yeah, okay. Yeah, so that's only relevant for that first section. All the other oh, okay, I see. You can use and, or you can use just 289. Yeah, I don't really care about that. Use those in decimals. Yeah, you could technically use those in decimals. Like, well, I say like 200 and 250,000. Yeah, a lot of people say and in the middle, which is fine. I don't really care, to be perfectly honest. So there are assignments for chapter 9, Nixon. Are we going to cover those? Yeah, so for chapter 9, I'm going to, so Stacy, I'm going to go ahead and chapter 9 we're going to skip here, and we'll come back to that a bit later. Okay, so I want to cover the basics here first. So I know chapter 9's kind of mixed in there, but yeah, you can skip those for now. The ones that I want you to focus on are the ones that I cover here in the lecture, so to make it as easy as possible. So you don't have the code for MyMathLab yet. What should I do? You can purchase the code on through mymathlab.com and follow the instructions there. So you can purchase that with a credit card. Otherwise, if you have financial aid, you must go through the bookstore. So that way you're properly compensated. It just depends what your situation is. I don't know, but hey. So there's instructions on D2L about how to register for MyMathLab and stuff. Yeah, that's correct, Hannah. Yeah, it's if that's the price, 104. It varies from book to book. So $114 and includes the e-text, and you should be good. once you get it. You can purchase an access code directly from mymathlab.com. Okay, that's fine. If you're waiting to get it shipped to your house, that's okay. You know, that's not everything is online orders and pickup only. Okay, so I totally understand. Like, I know for some people they're still waiting for their stuff. That's why I don't like set due dates to be right away, because I know that usually there are issues with that. So no worries. Where do you find the videos and notes? Um, okay, so for really quick, Maricela, sorry. The uh, the videos here are going to be up here on Twitch for 14 days. All right. I will, after 24 hours, according to the Twitch guidelines, I'll be uploading that to YouTube. All right. So 24 hours from now, I'll be uploading that this video here up to YouTube on my YouTube channel at Professor Chibs. All right. And the notes here, you can find the notes here, especially for like 1.4 here. You can go ahead and find that there on the D2L. It's underneath content, so in documents and whatnot. So you can actually find this to kind of follow along there, and that'll be available for you. So I try and put it in multiple places, the videos, so you can reference back. The YouTube is basically like a permanent home for our lectures. Twitch only holds it for 14 days, so that's why I export it from here after 24 hours over to my YouTube channel there. So just letting you know. Are there any other questions you guys got before we move forward? No. There's no grade for completion of the notes. I know it's put up there in terms of uh like the week to week thing, but that wasn't made by me. That was made by the course coordinator. So for me, I don't have you like complete notes for a grade or something like that. You have to show me that. So no. Do you have to get the access code for the book and the MyMathLab code? The access code is the MyMathLab code. So you get the access code, and then you have the course ID, which can be found underneath, again, announcements on the D2L page. And then, again, that'll link to the textbook there. You'll get an e-text with that. So access code, MyMathLab code are the same thing. And then the course ID will be linked to with our class here. So anything else before we move on? All right. Let's go ahead and move on here. All right, so we're going to be talking about multiplication here in this next section. No problem, Alyssa. So let's move on to multiplication here. Let's talk about some of the keys here, the keywords, okay? Keywords here are going to be product, okay? Product is definitely a word. Multiply, definitely one of those words there. Let's see here. Pass on that. All right, so those are probably the two biggest ones here. Now, let's talk about the keys here for multiplication. Now, multiplication for a lot of people can be a bit tough, but what is the key here? Now, the key here is to memorize, or try to memorize, at least try. Try to memorize the multiplication table up to 12. Okay, the most common multiplication tables are 1 to 10 or 1 to 12. Those are the most common here. Now, I have one that I brought up here. So let me, I'm just going to highlight this here. Whoop, from my second monitor. So some of you may have this multiplication chart, okay? And this multiplication chart goes from 1 to 12. Will you let us use calculators? Yes, but you'll have to show me the work on certain problems. Okay, so certain problems you'll still have to show me the work by hand, Hannah. Remember what this class is for is to help you build your math base, from the ground up. So again, having that mental math is just as important here in this class. So some parts here will definitely use the calculators, but again, some parts I want to see how you derived your work. So I'm trying to get you to that point so that way you can do mental math, quickly if you can, and also be able to use a calculator for tougher problems, because admittedly there are some problems that are rather tough, with without a calculator, so which I totally understand. So all right, so here you can see the multiplication charts. All right, so you can see what happens if you multiply by 1, multiply by 2, all the way down to 12. This little chart here is very, very helpful. Okay, the reason is that again, if you memorize this chart to some degree, all right, it makes doing mental calculations a lot faster. Even if you're going up to college algebra or heck even calculus or whatever, all right, and I know some of you probably won't, but the idea is that the idea behind memorizing this chart, if you can, is that it makes doing problems a lot faster. So, because sometimes you may be doing a process that requires, a lot of, a couple moving parts or a lot of moving parts, and then, you have to kind of do those little itty bitty details to do, say, the multiplication in that particular problem or whatever. Yeah, then having that kind of mental math is very helpful. So, you're not necessarily uh, stopping and starting necessarily all the time if you want to go through it a little bit faster. Now, do you have to? The answer is no, of course not. Like I said before, you should be able to go at your own pace, that you will be able to find the answer in a more consistent manner. So I'm not saying, oh, yeah, you have to memorize this. I say try to memorize it. It is very helpful. Um, 12 is the most common. You go up to 12 because most of the time in textbooks, in terms of like mental math, up to 12 is usually the typical stopping point. So beyond that, if you want to memorize those, you can, but I always recommend 12. I kind of, when I was younger, I kind of memorized up to 12, and that was about it. So I was like, okay, that's fine. And this little multiplication table will also help us for division as well. So we're going to come back and, of course, use this time and time again. So having this little multiplication chart handy should be fairly helpful. A calculator can be helpful in certain circumstances, which definitely is true, but you'll see that this little multiplication table will be useful if we want to reference certain numbers on here as well. Now let's talk about how we can do multiplication by hand. Let's go ahead and see how that will happen. All right, so let's go to how we can do this here. So let's talk about the key to multiplication. So the key to multiplication is using what I like to call the crossout rule. So okay, we're going to use the cross-out rule in order to at least understand how we can put this together. Okay, if we're trying to multiply bigger numbers, for example. Now, you'll see exactly how this works once we go ahead and use it, but we'll go over a few problems here and a few we'll go ahead and use a few problems here in order for us to kind of put this together. Let's look at some basic examples, and then we'll work our way up for examples. So, all right. Now, the first thing that it says here in page 30 of your notes here, is identify the factors in the product in each problem. Now, factors are basically the numbers that basically make up the product itself. So let me go ahead and write that out here. So let's talk about factors. Factors are the number or numbers, numbers when multiplied make up the final product. Okay, so in this case, if I have, so let's go back here for example, 8 times 5 equals 40. So if I have 8 times 5 equals 40, then our factors here are going to be 8 and 5, because those two numbers help us multiply to 40. And our product here, what happens after we put them together? You get 40 straight up. So 8 times 5 is equal to 40 here in that regard. You can even, again, break this down even further. Again, if you want to break this down further, we'll look at, like, say, prime factors. We'll look at that a little bit later. But again, these are the basic factors here. In order to get 40 would be 8 times 5. All right, any questions about that? That one's pretty straightforward, so that shouldn't be too much of a problem. Okay. All right. Okay, next, multiplication follows the commutative property. Okay, remember the commutative property. I said you can for some parts. You can use the calculator for some parts, but I need to see you do the work, Hannah. Okay. All right. So multiplication follows the commutative property. If you remember here, the commutative property we use for addition, such as A times B is the same thing as B times A. If we just flip the numbers around, you get the same answer regardless. Okay, so again, if I said 2 times 5, which is 10, is equal to the same thing as 5 times 2. Okay, so if we flip the numbers around, there's no, there's no way to really worry about how that's going to met out. Yeah, all right, let's do that. Okay. Okay. Let's also talk about ways to write multiplication. Now you're going to see me write multiplication, and maybe in this guide, you'll see multiplication written several different ways. So I just want to show you, say, hey, how do I write certain ways to express multiplication? Well, again, the first way to write multiplication here would be like A with a star here, A times B. That's one way to write, so like 1 times 5 or whatever. Another way is A with the X here in the middle. Okay, so A times B, just like so. All right, so again with the cross here in the middle. Another way to write this would be, again, put an A here in parentheses and a B here. This would also represent multiplication. Again, you can reverse this around. You could put the B in parentheses and that would be perfectly acceptable. And is anybody else freezing, or is everybody else good? Okay. Okay. Yvonne, just go ahead and hit F5 to refresh. Okay. All right. And then the last way we're going to put is that you can put them both in parentheses, just like so, A times B. So you'll see a lot of examples that will show off one of these 5 ways to write multiplication. There's a lot of different ways to write multiplication here, in order to, to express multiplication here. Yvonne, did it work? I hope it did. All right. Okay. Let's also talk about another property here. Okay, no problem. Cool. All right. We're getting to examples here. Property of 0. Okay, so for multiplication here, all right, property of 0, 0 times 0 times any number here, no matter what number it's going to be, is 0. It doesn't matter which way you write it, a times 0 or 0 times a, whatever. Anything you multiply is automatically 0. It doesn't matter. Okay, so 0 times whatever is always 0. And then there's also, of course, the property of 1. Go ahead and hit F5 there. So okay, and then there's the property of 1. Property of 1 basically says 1 times a is equal to that original number a. So 1 times 5 is 5, for example. Or again, if you reverse it around, it's the same exact thing. So 1 doesn't effectively do anything. It just basically keeps the same number that you multiplied with. No problemo. Okay, so that's the property of 0 and the property of 1. Cool. All right. So let's look at some problems here with let's actually let's also look at a couple more properties actually, now that I'm thinking about it. I'm going to call this the properties of tens. Okay. The next one here is the properties of tens. So basically, if you multiply, by a power of 10, examples of this would be, say, 10 or 100 or 1,000, etc. Okay, so if you, all right, just add the amount of zeros. Oops. All right, cool. To the end of the number. Okay, so let's go ahead and show that off here really quick. All right, so if I had And if I had 55 times 100, all right. Yeah, so if the stream stops for whatever reason and my stream is still working, just hit F5 to refresh so you can get back to where we are. So just as a future reference. You could just take 55 times 1 and just add the numbers. So 55 times 1 is going to be 55, and then add the 2 zeros at the end, 5500. Okay. So let me add a little bit to this. So just add the number zeros to the end after multiplying the other numbers together. Let's do another one here really quick, and then yeah, we'll do that. Yeah. So what if I had 12 times 80? Now you could do 12 times 80 here, but the way we look at this is we say, all right, let's do 12 times 8 first, all right? So we have, essentially, in this case here, we have 1 0. We have 1 0 that we're going to add at the end. All right? So what I'm going to do here is I'm going to do 12 times 8, because those are the regular numbers that we see. Now, if we go to our times table here for just a minute, where are you? There you are. If we go to our times table here, so we have 12 times 8. We look here on the times table, that's 96. All right, so that's 96 there according to our times table. So 12 times 8 is 96, and then we just tack on a 0 here at the end. So we get 960. That's essentially how the properties of tens work here. Will you be able to use a times table? Yes. But like I said, if you're going to do mental math in the future, make sure you could try and memorize the times table there. Like I said, try. Okay. Okay. All right, there you go. Perfect. Perfect. Okay. All right, let's go over some more problems here. Oh yeah, I gotta do something about that. Okay. Yeah, you're not wrong about that. 47, 14, 8. All right, let's do that. Okay. All right, let's go ahead and erase this. All right. So we're going to go ahead and yeah, let's do that there. There we go. All right. So we're going to go ahead and do this out here. We're going to do some multiplication using a few methods here, but we'll see how to do it on the basic, and then we'll take a look at the cross out method here about how to do multiplication. So I'm going to start off with something. I know this is going to be a little tough, but I'm going to go ahead and use letter E here of 4714 times 8, and we'll see how we basically use this with just a single number and then we'll kind of work our way up from there. Okay, so if we're taking a look at this here, all right, with 4714 times 8, what we're going to do here is we're just going to multiply starting from the right hand side and working our way left. And just like addition, we're just going to take the tens digit and then add it to whatever we have here in the next column over. Now let's see how this works. All right, so let's kind of go down the line here and let's see what we get. All right, so here we have 8 times 4, or 4 times 8, either way. So what's 4 times 8 here? What's 4 times 8? Okay, 32 is correct. So we're going to go ahead and put a 2 here for 32. And I'm going to carry the 3 up here. Now the way this is going to work, for doing this by hand, we're going to do 8 times 1. So I'm going to do 8 times 1, or 1 times 8. So let's do 8 times 1. This is a side scratch work here. And then I'm going to add the 3 to that. Okay, so 8 times 1 plus 3. Okay, so what's 8 times 1 plus 3? All right, very good. So that's 11. So I'm going to put 1 here for the 1 on the right, and then put a 1 here once again. So now I'm going to do 8 times 7 plus 1. Carry the 1, yes. 8 times 7 plus 1. What's that going to be? I agree that's the answer. We're just trying to come up with it. Just going step by step here. 54, that's close. Not quite. So do 8 times 7. So if you take a look at your multiplication table there, will be 56. Yeah, so this will be 56 here. And then you add the 1 to that, so this will be 57. Okay. So this is where we can justify the 7 from, in that case. And because this is 57, we're going to carry the 5 here. And so the last part here is going to be 8. Yeah. 8 times 4. All right. Plus 5. So 8 times 4 plus 5 would be 37. That's correct. So 37,000. Spot on, everybody. So 37,712 would be your final answer for this problem. Yeah, let's do that. Okay, good stuff. So far, so bueno. Noish. All right. All right. Let's do another problem here. All right. Okay. Now this one here, we're going to use what's called the cross-out method. Now I only have like 5 minutes left or so. So I'm going to kind of go over this one a little bit quickly, but I want to just show off what the cross-out method will do with 2 random numbers that we're multiplying here together. Okay, so let's let's go ahead and see how this is going to work out. There we go. All right, so let's put in what two numbers I want to choose. Okay, I know. So we're just going to do 89 times 25. All right, so 89 times 25. Okay, so I'm just going to go over this a little carefully, all right, and you'll see exactly how I come up with this answer. Now, trust me, for next time, I'm going to start with another one of these examples here. We'll get to division, we'll do another section, but I just want to show this off here before the end of class here today, so you have a good idea about how to tackle these problems if you're doing these by hand. Again, you'll have to show me how to do these by hand, so kind of one of those things. All right, so we're going to proceed to do the same thing here. With the crossout method, the crossout method says, I'm going to proceed to do this. I'm saying, okay, 9 times 5. Now, 9 times 5 here is going to be 45. So I'm going to put a 5 here and carry the 4. So I do 5 times 8, which is 40, plus 4, which is 44. Now, in the crossout method, all right, in the crossout method, basically, you're going to basically cross out the first column, or the first column, when you do the next number over. So you do, I basically am going to cross it out just like so. This cross out here represents 0. I don't like putting 0 there because it makes it confusing. But I do like putting a cross out here because it tells me where I need to start, which is the next column to the left. Okay. If I have 3 numbers here, I'm going to cross out 2 times here. Okay. So basically, I'm going to go with 2. 2 times 9 is 18. Now this 4 is gone now, so I'm not going to acknowledge this 4 anymore. But I have 18 here, now I got a 1. And 8 times 2 is 7, plus 1 is 17. So I put a 7 here, and I put a 1 here, just like so. Now since I'm considering this 5 here, this 5 and this x here to be a 0, I then go ahead and add straight down here. So I have 5 plus 0, which is 5. 4 plus 8, which is 12. Carry the 1 here. 7 plus 4, 11 plus 1 is 12. Carry the 1 again. And I get 2. So 2225 here is what I get for my final result. So of course, I'm going to talk more about this in the next class here coming up on Thursday. But I do want to kind of preview here about, how to do the crossout method. I call it the crossout method because it kind of reflects like what a baseball score is. You cross out the number of innings the home team doesn't play. So, that's how we can go ahead and approach this. Now, of course, one example isn't enough. And like I said, I will do the other one here. I'll do some more examples in regards to this for next time. But it gives you a pretty good idea about how to approach extra numbers in the mix by hand, about how to do multiplication. Are there any questions about that? So I apologize if I know I kind of rushed that last part there, but we're going to do some more examples here for next time, and we'll see exactly how we can get that done. So shouldn't be all that bad. Okay. Nope. Okay. Good beans. All right. So that'll take care of it for today, everybody. All right. So good job here today, everybody. All right. So that will take care of those two sections for now. We'll come back on Thursday and we're going to start up here doing a couple more examples of multiplication using the cross-sum method. I'll expand upon that in a few more details here, and then we'll get to division here, and then we're going to get to order of operations as well. All right, so if you want to keep up with the homework here, then sections 1, 3, and 1.4 will be, if you want to keep up with the homework here, sections 1, 3, and 1.4 will be your homework if you want to keep up from what we have done here so far. All right, so remember that homework is not due until the day of the test, and I have not announced the test yet. So, yeah, so it's not going to be due for a little while. Any other questions? All right. So I want to thank you, everybody, for coming out today. Like I said, we'll do a few more examples here of the cross-out method. We'll see exactly how that works, okay? Because obviously one example is definitely not enough. But we will see you all on Thursday, all right? So this replay here will be up on Twitch right away, but the permanent home will be on the YouTube channel, so after 24 hours. All right. So that'll take care of it here for today. We will see you here in a couple days on Thursday. Everyone have a wonderful morning / day, and I hope to see you all here again soon. Again, feel free to contact me if you have any more questions, okay? All right. Take care, everybody, and we will see you later. All right. If you're here for my 11 o'clock class, I will be up here in approximately 5 to 7 minutes. All right. Have a great one, everyone, and we will see you later. Take care. All right.